This is 2.1 rectangular coordinates part 1. This section will be divided into two pieces just for length of the video. There's a lot of calculations to do, so it takes a little bit longer. So we're going to start by taking some coordinates and figuring out their distance and midpoint, which means we're going to need to remember our distance and midpoint formulas. So let's start with distance. Distance is the square root of our x values being subtracted from each other. So the difference of our x values, that quantity squared, plus the square of the difference of our y values. So you have x1 minus x2 squared plus y1 minus y2 squared. So let's start by finding the distance. So we are going to take, it doesn't matter which x value you start with, so we just take 1 minus 4 squared plus 7 minus negative 5, so that's really 7 plus 5. And then we simplify. So 1 minus 4 is negative 3, but negative 3 squared is 9. 7 plus 5 is 12, but 12 squared is 144. So we end up with the square root of 153. And when you get down to that point where you're finding the square root, you want to look to see if there's a perfect square that divides evenly into that so that you can simplify. And 9 goes into 153 17 times. So we would say the square root of 9 times the square root of 17 is the same as the square root of 153. And then we can simplify the square root of 9. So we have 3 radical square root of 17. And that's our distance. Now midpoint, if you remember from geometry, is an average. So we are going to average our x values because it's in the middle. Middle, average, kind of help you remember. So we're going to take 1 plus 4, because remember when you average something, you add them together and divide by however many there are. So we're going to add the two x values and divide by 2, because there's 2 of them. Now the midpoint is a point, so we have an x value and then a y value. So now we're going to add the two y values together, 7 plus negative 5, and divide it by 2, because we're going to average those y values. And then we simplify. So 1 plus 4 divided by 2, that's 2.5. And 7 plus negative 5 divided by 2 is 1. The midpoint formula in general.
Don Carl, could you please come to the front desk of Lee Summit North? Don Carl, please come to the front desk of Lee Summit North.
Please excuse that. All right, the actual midpoint formula, if you would like to know, is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Okay, so we just average the x's and average the y's to get a point that would be the middle of those two. All right, now the reason why we need to review those two equations is because we are going to use them to determine what type of triangle we have given just some random coordinates. So again, we're going to have to review some things from geometry here. There's 3 different types of triangles. We have the isosceles triangle. Remember, that means that there are 2 sides that are equal to each other. We have the scalene triangle that has no sides equal. And we have the equilateral triangle, which is all sides equal. Okay, so we can use the distance formula to figure out the length of each side to determine, is it going to be an isosceles, a scalene, or an equilateral. Now, I think it's helpful to label these with some letters, A, B, and C. You can use any 3 letters. Those are just an easy ones to pick. So then we can keep our side straight. Let's find the length of side AB. So we're going to use the distance formula. We're going to do our x minus x squared plus our y minus y squared. Simplify all of that and we get the square root of 50. Find a perfect square, which is 25. Break it down, we get 5 radical 2. Now I know those calculations I'm going through pretty quickly. You can always push pause, simplify yourself, and then come back and check to see if you did it correctly. Next, I'm going to take BC and find the length of that side. So here's a good time for you to practice. Hit pause, see if you can find the length of BC, and then come back. So we have 0 minus 4 squared plus negative 3 plus 4 squared equals the square root of 17. That does not break down, and so far since these are different, we can rule out that it's equilateral. So now it might be isosceles because we could get another one that's the same, or it might be scalene where they're all different. So last side that we need to try is AC. We're going to find the length of it. 5 minus 4 squared plus 2 plus 4 squared equals the square root of 37. And we have discovered, since all 3 of these are different side lengths, that this must be a scalene triangle. Now, naming a triangle by its side is not the only way that we name it. We also name triangles by angles, specifically finding out whether or not it's a right triangle. Okay, so one way to find out if it's a right triangle is to determine if any of the sides make a right angle. You all probably remember that a right angle or a right triangle has to have a 90-degree angle, which means that 2 sides have to be perpendicular to each other. In order to make a 90-degree angle, 2 of the the triangle sides have to be perpendicular. That's the symbol for perpendicular. So to determine if they're perpendicular, now we get to go back to algebra 1, we use slope. Remember, slope is y1 minus y2 over x1 minus x2. Okay, and if we find the slopes, and the slopes turn out to be opposite reciprocals, then they are perpendicular to each other, which makes them 90 degrees, which makes it a right triangle. So now we need to do the same thing we just did over here, but find slopes. So we need to find the slope of AB. So we're going to do 2 plus 3, see our y values, over 5 minus 0. We get 5 over 5, which is 1. Then we're going to find the slope of BC. And again, this would be a good time to hit pause, find the slope of BC and find the slope of AC, and then come back and check it. We have negative 3 plus 4 over 0 minus 4 equals negative 1/4. So those two are not opposite reciprocals. We'll have to check this last one. So AC, we have 2 plus 4 over 5 minus 4 equals 6. All right, so none of these are opposite reciprocals of each other. So what we just proved is that this is not a right triangle. Okay, so we know it's scalene, and we know, oops, sorry, scoot that over. We know that it is not a right triangle. So a lot of calculations there, not difficult calculations, but a lot of arithmetic that we have to do. Let's try one more of those, determine what type of triangle we're gonna have. So I would like for you to write that down and then pause, solve it all out. Do all of the distances, do all of the slopes, and figure out what type it is, and then come back and check. All right, let's start with, again, I'm going to label these A, B, and C. I'm going to start with AB. To find AB, we're going to do -3 plus 1 squared plus 2 minus 5 squared, which equals the square root of 13. Then I'll do BC. -1 plus 6 squared plus 5 minus 4 squared, which equals square root of 26. And then we also have AC. So again, we know it's not equilateral at this point, but maybe it could be isosceles or scalene. Equals square root of 13. All right, so there we go. Those two matching sides tell us that we are going to have an isosceles triangle. But then we need to know if it's right or not. So we need to use slopes. So AB, we're going to do 2 minus 5 over -3 plus 1 to find out that it is 3/2. Doesn't mean anything until we find the others. So we have 5 minus 4 over -1 plus 6, because it was a -6, equals 1 over 5. So those are not perpendicular. So no right triangle yet. So AC, we have 4 minus 2 and -6 plus 3, which gives us 2 over -3, or -2/3. And looky there, 3/2 and -2/3, those two are opposite reciprocals of each other. They're the opposite sign. One is positive, one is negative, and you can see that they've been flipped, so that means it's a reciprocal. So we have a right triangle. So we have an isosceles right triangle. All right, hopefully you got that. That's all for the part 1 of 2.1, and then part 2, we're going to talk about circles.